So Kayo Sports has been built and designed for the streaming generation, so it's available on all the devices that you would expect, web and all the major browsers. It's also bespoke apps that are available on Android, iOS, phone, tablet and Apple TV, and we're also building out a range of new TV app devices and console devices over the coming 6 to 12 months.
We use AWS Elemental Live on-prem here to push our content out to AWS Elemental Media Package. We use features in Media Package such as timeshift viewing. That enables us to do DVR and VOD mode type events. It allows us to come straight in live on edge. It also allows the user to come in right at the start of the match so they're not missing anything. What we also do is via our stats department here, we offer up key moments which we can overlay on the scrubber. So the end user doesn't miss any bit of action when they come into the event that we're streaming. If they come into the match, 2 hours into a cricket match, they can rewind and go back and see all the highlights and then jump back to the edge and sort of get a quick highlights view of what's happened in the match. We always try to ensure that we're providing the lowest visual latency for the end user. Everyone hates getting a notification on a phone before they've seen the event on the TV. And so there's technologies we're playing around with AWS in terms of chunk transfer, and as that becomes part of the full transmission chain, we'll start rolling things like that out as well. First thing, we try to keep the segment size as small as possible. What we also do is we try to keep the least amount of processing on the video chain as we can. So we have AWS Elemental Live ground encoders on our broadcast facility where the content's produced. We encode one output here and then we push up to AWS Elemental Media Package where we do transcode to multiple other formats, and we do all that via direct connects we have into AWS infrastructure. So AWS Elemental Media Package allows us to repackage our content from what we push from our on-ground live encoders. It takes the overhead of our encoding. We only send it one output and then we're able to transcode multiple different formats at the edge. Also, we're able to utilize AWS Media Package API services. So we have an in-house automation platform that we built here, and we'd be able to plug into the APIs and automate scheduling up to 300 to 400 events in Media Package, where traditionally someone would have to log into the console and configure each event or each channel. In Media Package, we've been able to automate that and make a lot of efficiencies. The benefits of AWS video infrastructure, it allows us to scale instantly. Literally, we can spin up channels and events in seconds. If we were to do that on ground, we'd have to wait for the shipment of the equipment to come in, we'd have to wait for the engineers to install it, and then at the end of the whole event, what do we do with that infrastructure? We've got to sweat those assets. Future-proofing is a big benefit also. It allows us to move quickly when new features come out. Also, with our changing workflows day to day, it allows us to move quickly in that area as well. We run all of our APIs and services on Amazon EC2. It's quite important that when we have peak loads or large scheduled events that we can auto-scale to handle that capacity. At the same time, it's quite important that we can scale back and make sure that we can keep some control of our costs. It was identified early on in the project that we needed to get the data piece right, so the obvious choice was to build our own data lake. We wanted to contain that or control that in-house, and so we went with AWS because it had all the services that we needed to spin that up quickly. What we do with the data lake is we process all of our video quality of service metrics along with our user behavior and other stuff like that. In terms of performance and enablement, it's doing a great job. We have what we call a landing layer where all the raw data from all our ingest sources come in. We then transform that data into a sourcing layer. That's where the data is cleansed and anonymized. We then throw over the top of it a schema and we expose that via Athena, another AWS service that we found very, very helpful. In terms of our lifecycle policy, all of our data sits on S3. We do have versioning amongst our data, and then in terms of the lifecycle, we do move those versions, older versions, down to Glacier, where we can have some more cost savings. We use AWS Step Functions and Lambda on our asynchronous orchestration flows. AWS Step Function and Lambda allowed us to scale up and deploy the platform quite quickly. It removed a lot of the DevOps overhead we would have had if we had to manage our own messaging systems and orchestration platforms on EC2. We're still young and we have a lot of improvements and new features to come for our users. Anyone can go and get the latest tech and install it and make something happen, but I think what we have going on here at Kayo Sports is quite important.